f of negative 2 is going to equal, if I go back negative 2, it's going to equal a positive 1. So to evaluate this function, I can look at the graph. I could have also said f of 2 and gone, where does 2 in all this? It's right here. So I'd put negative 2 plus 1 gives me a negative 1. My negative 2 down here fits here, so I'd have negative 2 plus 3 equals 1. So I can look at it several different ways. Now, a piecewise function can have many, many pieces of functions. So if I look at this next function, I have one piece here. So this is A. I have another piece that ends from there to there. This is B. I have this piece C. And then I have this little piece right here, which is D. Okay? And so if I'm looking at this again, I'm going to chart my domains. So in this case, I have negative 4 to negative 2. Okay, so my x is going to be less than or equal to, less than or equal to. This goes from negative 2 to a positive 1. So negative 2 to positive 1. Now I've already said this line equals negative 2. I can't have two of them. So this is just going to be negative 2 is less than x, which is less than or equal to 1. And again, now I have less than or equal to 1, so this one can't equal 1. And so that will go from 1 to 3. And my x will be less than or equal to 3 and less than, or I'm sorry, my x will be greater than 1. Again, I'm going to put another x in here, and this goes to 4. And I'll do my less than signs. So what I've really got is I've got this function, this one, 3, 4, and they share domains. So in this case, I've got one piece that goes from negative 4 is less than or equal to x, which is less than or equal to negative 2. My second part is from negative 2, which is less than x, which is less than or equal to 1. My third part goes from 1, which is less than x, which is less than or equal to 3. And then my final part will go from 3, which will be less than x, which is less than or equal to 4. And you'll note that this one equals 1, this one almost equals 1. This equals 3, this one almost equals 3. So these are my domains, which is how I start my functions. Now I need to come up with what will y equal when x is between negative 4 and 2. So here I have a constant function. Y is always going to equal 2 when x is between negative 4 and negative 2. So if I say, what's x at negative 3? Well, y is 2. Okay? Now when I go between negative 2 and positive 1, I can look and see that I have a negative 1 slope, so it's a negative x, and it goes through the origin. So this is just negative x when x is between negative 2 and 1. My c again is a constant function, so it'll be at negative 1 when x is between 1 and 3. And then my last one is teeny tiny. I go up 1 and over 1, and that's going to be at x. But the problem is now I can't tell you where my y-intercept is. I could, but let's say I can't. Okay, so now I have y equals x plus b, because I can tell you my slope, but I can't tell you my intercept. And so I'll take a point on this line, which I'm going to take 4, 0. I could have also taken 3, negative 1. I can take either one. In fact, I will take 3, negative 1. I make my y equal to my y point, so negative 1 equals my x, 3 plus b. Subtract 3, and negative 4 equals b. So now I have y equals x minus 4 when x is greater than 3 n less than or equal to 4. So when you're doing these piecewise functions, you have to actually look at this piece, this piece, this piece, then this piece. Don't group it all together. It becomes overpowering. My next, now, and